Topic 5, Geometry and Measures. Pythagoras Theorem. Pythagoras Theorem is used to find the lengths on a right-angled triangle. The longest side in the right-angled triangle is called the hypotenuse. And Pythagoras Theorem states that for any right angle, the square of the hypotenuse is equal to the sum of the square of the two other sides. Now for this triangle, for a right-angled triangle, we label the hypotenuse as side C and the other two sides as A and B. And sometimes I suppose, yes, you could label the hypotenuse as H, but generally because we're calling the other two sides A and B, we just tend to go for A squared plus B squared equals C squared. So to find the side using Pythagoras Theorem, we should always draw the triangle and then label the sides A, B and C. Then we rewrite Pythagoras Theorem and we substitute in the values of the known sides, and then we can work it out from there. Remember, the hypotenuse is the longest side, so our answer should be in relation to that. So if we're asked to find the hypotenuse, our answer should be bigger than the other two sides. But if we're asked to find one of the shorter sides, then they should be, if we get an answer that's longer than the hypotenuse, then we know we've clearly made something wrong. Example 1, in triangle ABC, angle B equals 90 degrees. So the way we've got this B with the arrow above it just means angle B. So that's 90, AB is 10 and BC is 14. Find the lengths of AC. So what we need to do first of all is draw a right angle triangle and label the right angle B. And then the other two sides are A and C. It says AB is 10, so that's the line connecting points A to B. So that means the height of this triangle is 10. BC is 14, so B to C is 14, so the base then is going to be 14. And what we're trying to do is find AC. So what we need to do is use Pythagoras Theorem, so A squared plus B squared equals C squared, where C is the hypotenuse. So we're going to label the side AC as C, and then it doesn't really matter which way around we go for A and B. Now we can substitute in values. So we know that side A is 10 centimeters long, so it's going to be 10 squared, and B is 14, so that's 14 squared, and that's C squared. So we don't know its value, so we're going to leave it as C. So we can work out 10 squared to be 100, and 14 squared is 196, so that still equals C squared. Adding 100 and 196, we get 296 is C squared. Then to find C, we have to do the square root of 296. So C will work out to be 17.20 centimeters to 2 decimal places. Example 2, in triangle PQR, angle P is 90, PR is 5.3 and QR is 11.5. Find the length PQR. So let's draw a right angle triangle and let's mix it up to be different. So we've got the right angle at the top and it's P, and then we've got Q and R at the other two vertices. So we're told that PR, so P to R is 5.3, let's label that as 5.3. QR, so Q to R is 11.5, and then we want to find PQ. So Pythagoras Theorem is A squared plus B squared equals C squared. So let's label the sides. C is the hypotenuse, which is the one opposite the right angle. So that means that QR is C. And then we've got A and B are the other two sides in any order. So if we substitute them in, we don't know the value of A, so let's leave it as A squared. And then B is 5.3, and that's going to be squared, equals 11.5 squared. A squared plus the square of 5.3, which is 28.09, is going to equal 11.5 squared, which is 132.25. What we want to do is get rid of the 28.09. So we'll move it to the other side, and to do that we'll take it away. So we get A squared equals 132.25 minus 28.09. So A squared 104.16 A then is the square root of 104.16, which is 10.21 centimeters. Now let's check if that makes sense. What we were trying to find was a shorter side, and our answer is 10.2, which is smaller than the hypotenuse, so that looks as if it's a sensible answer. Example 3, the length of the diagonal of a square is 10 centimeters. So let's draw that square. And we're told the diagonal is 10. And what we know about a square is that each corner is a right angle. So what we have here then is a right angle triangle, and we know the hypotenuse. And we also know that in a square, the two sides are the same. So let's call that x and x. So in Pythagoras theorem for a right angle triangle, a squared plus b squared equals c squared. C is the hypotenuse, so that's going to be the diagonal of the square, and a and b are the other two sides. So what we have is x squared plus x squared is 10 squared. Now x squared plus x squared, if we add those together, we can combine them to give 2x squared, and that equals 100. Now if 2x squared equals 100, then 1x squared is 50 by dividing by 2, and then x is going to be the square root of 50, which is 7.07. So the length of the square is 7.07. The area, well, that's x squared, because it's 7.07 times 7.07, which we know to be 50 squared centimeters. Example 4, show the triangle whose sides are 10, 24 and 26 as a right angle triangle. So to do that, we will draw a right angle triangle. We'll label the sides 10, 24 and 26. Now 26 is the longest side, so if it is a right angle triangle, it would have to be the hypotenuse. The base we'll call 10 and the height 24. So if this is a right angle triangle, then Pythagoras theorem holds. So then a squared plus b squared will equal c squared. C is the hypotenuse, so then it'll be the side 26. So let's fill in these values. And we'll have 10 squared plus 24 squared equals 26 squared. That's 100 plus 576. And 26 squared is 676. So what we have is that 676 equals 676. And because that's true, that means that this triangle is a right angle triangle. Had we got down to something that said 676 equals 690, well, that clearly is not true, so therefore it wouldn't have been a right angle triangle because Pythagoras theorem didn't hold, and Pythagoras theorem only applies to right angle triangles. So if we're showing that a triangle is a right angle triangle, we use Pythagoras theorem and it should work, so we get something that equals itself, which we know to be true. If it works out to be something different, then that implies that it's not a right angle triangle. Example 5, find the area of an equilateral triangle of side 6 centimeters. So let's draw our equilateral triangle. And we know that the three sides are equal. Now the area of a triangle is a half times the base times the perpendicular height. And the perpendicular height in this case would be here. Now we don't have that, but because of Pythagoras theorem, or thanks to Pythagoras theorem, we can look at that half triangle, which has a hypotenuse of 6 and a height of h, and the base length, which is going to be half the base of the original triangle, well, that's going to be 3. So now we've got this right half of the triangle, and that's because an equilateral triangle is symmetrical. So if we apply Pythagoras theorem here, a squared plus b squared equals c squared, where c is the hypotenuse. What we've got is h squared plus 3 squared equals 6 squared. H squared plus 9 equals 36. We need to move the 9 over to the other side and it'll become a takeaway. So we've h squared equals 36. Take away 9. H squared is 27. So h is the square root of 27. So h is 5.196 centimetres. So now we've got the height of the equilateral triangle. We can work out the area, and that's a half times the base of 6 times the perpendicular height, which is 5.196, which is 15.59 squared centimetres to 2 decimal places. Example 6, find the length of a line segment joining the points 1, 2 and 5, 9. Now what I'm going to do here is first of all draw a quick sketch of where these 2 points are. So 1, 2 will be here, which is an x coordinate of 1 and a y coordinate of 2. And 5, 9 will go along the corridor 5 and up the stairs 9 to get here. And this is our point. Now what we can do is we can form a right angle triangle, and hopefully it's clear here that the base length is going to be 4 and the height of the triangle is 7. And what we're doing is trying to find this length. So this is a right angle triangle. A squared plus b squared is c squared. C is the hypotenuse, so the one opposite the right angle. A and b are the 2 other sides. So we can fill those in to get 7 squared plus 4 squared equals c squared. 49 plus 16 is c squared. 65 then is c squared, so adding 49 and 16. And then the square root of 65 is c. So c works out to be 8.06 units. And we're not sure if it's centimetres or metres or whatever, so we can just leave the generic units. And that's to 2 decimal places.